Hi everyone, today we're going to be talking about solving systems of equations graphically. So the definition, you get two or more equations. And the types of solutions that there are going to be, if you have one solution, this is going to be intersecting lines. So where they intersect will be the actual solution, and you will write that as a point. So like an XY coordinate as a point. The other one is a no solution. No solutions means that you're going to actually have parallel lines, which means that they're never going to touch. So we will have parallel lines, and that's how you know that there will be no solutions. The next one is going to be the same line. So infinite solutions, if it's the same line, then all of these are actually going to be all the solutions. So same line, you'll have infinite solutions. Go ahead and zoom in so you can see it a little bit better. Okay, and then the one intercept form, the slope-intercept form we want to make sure that we are in is y equals mx plus b. We need to make sure we're in that form in order to actually be able to graph. So when we have our first example, we have y equals negative 5/3 x minus 6, and we also have y equals 1/6 x plus 5. So this means that we are already in y equals mx plus b, so we can just go ahead straight to start graphing. We end up graphing by doing the y-intercept. So you always start with the value that doesn't have the x. So I'm going to start with this first graph. On your y-axis is the y-intercept. I'm going to start at -6. And then I'm going to use my slope of -5 and then to the right 3. So let's make sure if I run out of room, 1, 2, 3, 4, 5, which I do, 1, 2, 3. I will put a dot right here, but I am going to be running out of room. So instead, I'm going to make the negative go to the 3. So I'm going to go up positive 5, 1, 2, 3, 4, 5, and then the negative is now on the 3, so I'm going to go left 3, 1, 2, 3. So I'm going to go ahead and connect those dots. That's for my one equation here. And then I'm going to graph my next line at a positive 5 on the y-axis, and then up 1 to the right 6. 1, 2, 3, 4, 5, 6. I like going down in the other direction too, 1, 2, 3, 4, 5, 6, because then I see where I'm supposed to actually run into my other graph. And my solution should be at -6, 4. So I have one solution, and the reason why is because my graphs intersect. Okay, I'm on the next example on the back side. Your example number 2, we're going to have a 3x plus 6y equals a -12. This is not in y equals mx plus b form, so I'm going to go ahead and put that in y equals mx plus b form first. So I have 6y equals a -3x minus 12. We're going to divide everything by 6, leaving me with y equals big numbers on the bottom, so I'm going to keep it as a fraction. And then we have a big number on top, so that's going to be a whole number. So now I get to graph this as -2. I'm going to use my slope of down 1 over to the right 2, down 1 to the right 2. Again, I can go in the opposite direction, negative going on the other side. So that is my line for this one. I'm going to go ahead and connect those dots real fast. And then your other equation is actually going to be in the slope-intercept form already. It's going to be a 1/2 x minus 5. So I see that I have -5 here, and I'm going to go down 1 to the right 2, down 1 to the right 2. Oh, if I go up to the 2, then I see that I actually don't have intersecting lines. They're just going to be parallel lines. And on the front, it actually told me that my parallel lines will never intersect. So I have no solution. Sorry, my parallel lines will be no solution. So there are 0. And the reason why is because we have parallel lines, which means they do not intersect. And then our last example we're going to have is a negative y equals -x minus 6. I have a negative here, so it's technically not alone, not in y equals mx plus b form. So now negative by negative is a positive, and I get a +6. I'm going to go ahead and graph that one. So 6 up 1 over 1, up 1 over 1. Remember, there is a little invisible 1 over 1, rise over run. You can also go in the other direction. And then, I just want to do more dots. The more accurate you are, the better you will be able to see your graph here. And then my other equation that I have is 3x plus 18 equals 3y. We're going to divide everything by 3, even though our y is on that side. It's okay. So we end up getting x plus 6 equals y. Oh, look, it's the same equation. So actually, I am going to be the same line. If I go to 6, up 1 over 1, it is the same line. I'm okay with you guys having the one line drawn, and that's it, because for your solutions, you're going to write infinite solutions, which means that I know that you have one single line there. And again, number of solutions will be infinite, because all of these are all solutions. And why? It's because it's the same line. Alright, so we have one example of each, and I will see you guys next time. Thank you.